Assalamualaikum and a very good day. My name is Emira Sofia and my student ID is 2021829752. And today I'm excited to share you my final year project on the preparation and the characterization of vitamin E loaded virgin coconut oil emulsion. Today I'll walk you through all of these topics. In this project, I focus on creating water in oil emulsion using virgin coconut oil loaded with vitamin E. And emulsion is essentially a mixture of two immersible liquids. So virgin coconut oil is chosen for its rich composition and health benefits. It is extracted from coconut milk and it is high in lauric acid, which is known for its antimicrobial property. So vitamin E is a powerful antioxidant essential for protecting cells against oxidative damage. It is widely used in skincare for its anti-aging properties. I had two main challenges, which is the first one, vitamin E tends to oxidize and has a high lipophilicity, making it less stable and effective. Next, the problem is that emulsions are inherently unstable because they are like oil and water, they don't mix without help. Hence, to tackle the problem, we can look into the objective of the study, which was first to create a stable virgin coconut oil emulsion loaded with vitamin E. And next is to characterize the emulsion in terms of its stability, pH value, and also particle size. So what is emulsion? Emulsion is like trying to mix oil and water in a bottle. Normally those things don't mix, but if you shake them hard enough, they will blend temporarily, indicating that it is very unstable. Essentially, there are two main types of emulsion, which is water in oil and oil in water emulsion. In my study, I focus on water in oil emulsion. So the stability of the emulsion influenced by several factors. One of them is surfactant. Surfactant are like the peacemaker in the mix. They help oil and water get along. They have a hydrophilic head and a hydrophobic tail, allowing them to form micelles, which are structures that help oil and water mix together. VCO is gaining popularity due to its numerous health benefits. It is extracted from fresh coconut milk without using chemicals or high temperature, so if VCO retains more of its natural compound compared to refined coconut oil. So the key property that it is rich in lauric acid. It has 50% of lauric acid, which has an antiviral property. Next, it also has an antioxidant property, gives skin, hair, and also dietary benefits. Vitamin E is known for its powerful antioxidant property. It exists in 8 chemical forms, but alpha-tocopherol is the most active form in humans and is the focus of most research. However, there are significant challenges when using vitamin E in formulation. The first one is vitamin E is prone to oxidation when exposed to air, light, and high temperature. Second one, it is very lipophilic, meaning it dissolves easily in fats but not in water. This makes it challenging to create a stable emulsion as it tends to separate out in a water-based solution. The methodology include determination of physiochemical properties of VCO, determination of HLB value for blend surfactant, preparation of VCO-based emulsion containing vitamin E, and lastly, characterization of emulsion system. As for the results, we have analyzed the physiochemical properties of the VCO, the HLB value for the blend surfactant, the characterization of the emulsion, the pH value of the emulsion, and lastly, the particle size of emulsion was analyzed under the polarized optical microscope. From the physiochemical test, we wanted to find out the moisture content and the free fatty acid content. So starting with the moisture content is the amount of water in a product. So according to the Asian and Pacific coconut community, the moisture content of a virgin coconut oil should be below 0.1%. So in my study, we found that the moisture content was slightly higher than the standard. With an average of 1.3%, it is quite a bit over the limit. So why is it so high? Well, there's a few reasons. The first reason is the extraction technique. So different methods like centrifugation or cold pressing can leave different moisture level. Cold pressing, for example, might not have removed all of the moisture. So second reason is storage condition. If the oil isn't properly stored, like in a high humidity or polysilk container, it can absorb more moisture. So the third one is sample handling. So how we handle the sample during the analysis can also affect the results. That is why proper drying and preparation are very crucial. The lastly is environmental factors. So the temperature and humidity changes during the manufacturing and also during analysis can impact moisture content. Now let's move on to the free fatty acid. So FFA in VCO are another quality measure. High level of FFA can spoil the taste and also reduce the shelf life. So in my study, we used titration with sodium hydroxide to measure the FFA content. So both samples have very low FFA levels, averaging in 0.1%. This is well within the APCC acceptable range of 0.25% to 1.3%, indicating a high quality oil. So low FFA levels means that the oil is very stable and has a long shelf life, which is great for food, cosmetic, and also pharmaceuticals. Next, let's move on to the HLB value. The value helps us to understand how well a surfactant can emulsify. We calculated the HLB value for a blend of Twin 80 and also Span 80, getting a final value of 4.8483. This is more on the lipophilic side, suitable for the water in oil emulsion. So next is FTIR analysis. So FTIR is a powerful analytical technique used to identify and characterize the molecular composition of a sample by detecting the vibrational modes of the chemical bond. So in this study, FTIR was crucial to confirming the presence of all of the components in the emulsion and understand its interaction. So from the first component, which is VCO, there's a distinct peak, which is OH stretching due to the hydroxy groups in the water or the free fatty acid in the oil, CH stretching from the methylene group in the fatty acid, carbonyl stretching due to the ester group present in the triglyceride, and also CH bending, which is the bending of the vibrational of the methylene and also methyl groups. Now let's analyze the vitamin E and water spectra. So from vitamin E, we can see the OH stretching indicates the presence of hydroxyl groups, CH stretching due to the aliphatic chain in the vitamin E, carbonyl stretching confirming the presence of ester group in the tocopherol component of vitamin E, CH bending, the bending of vibration of the aliphatic chain. So for the water, we can see the OH stretching a broad absorption band due to the hydrogen bonding. Now let's move on to the surfactant, which is Span 80 and also Twin 80. So for Span 80, we can see the CH stretching, which is typical of aliphatic chain. We can also see carbonyl stretching, indicating the presence of ester group. So for Twin 80, we can also see CH stretching and carbonyl stretching similar to Span 80. But we can also see COC stretching due to the polyoxyethylene chain in the Twin 80. The spectrum of the full emulsion incorporates peaks from all of the individual components. So we can see OH stretching from water, vitamin E, and VCO, CH stretching from the aliphatic chain of VCO, vitamin E, and also the surfactants, carbonyl stretching from the triglyceride in the VCO and ester in the surfactant, CH bending from the methylene and methyl groups in surfactants, vitamin E, and VCO, and lastly the COC stretching from the Twin 80. So this comprehensive spectrum confirms that all of the intended components are present in the final emulsion. So this indicating the successful formulation. The presence of these characteristic peaks ensures that the emulsion retains the functional properties of its individual components, contributing to the overall stability and also efficiency. Next is centrifugation. So it helps assesses emulsion stability by using centrifugal force to detect phase separation. So I found that emulsion homogenized at 9000 RPM for 20 and 30 minutes was the most stable, with minimal to no separation at all. This suggests that higher speed and longer duration improve its stability. So the next stability test is freeze-thaw. We tested how emulsion stood up to freezing and thawing. So initially it stayed uniform, but at the third cycle we saw some phase separation. This indicates that repeated freezing and thawing may destabilize the emulsion, highlighting the need for a robust formulation technique. So let's move on to the pH. So the pH of the emulsion stayed relatively stable, dropping slightly from 6.26 on day 1 to 6.14 on day 35. So this small pH decrease that have seen in the 35 days may have an effect on the emulsion's longevity, especially with regard to the oxidation and antioxidant activity. So this small change indicates a good stability, but it is very crucial to monitor the pH to ensure a long-term product quality. Lastly, we use polarized optical microscope to measure the droplet size. So the droplet size ranging from 20 to 47 micrometer, classifying the emulsion as a macro emulsion. So a variation of droplet size indicates that the emulsifier may not have produced a homogeneous droplet size to the fullest extent possible. So a smaller and uniform droplets usually means more stable emulsion, while a larger droplets can lead to phase separation over time. So the macro emulsion is actually a size range that is suitable for many industrial applications. Let's conclude with the key findings of my study. First, we found out that VCO has the moisture content of 1.35% and FFA of 0.1%. Both meets the standard set by APCC. So the first objective, which was to prepare a stable emulsion, we tried out different homogenizer speed and time to see what works best. Then we conducted a centrifuge test to find out the most stable emulsion. Finally, we found out that the most stable emulsion was at 9,000 RPM for 30 minutes. So moving on to our second objective, which was to characterize the emulsion. We confirmed that its stability through freeze-thaw cycle tests. We also checked the pH and it stayed stable between 6.14 and to 6.26. Finally, we look at the droplet size, which is ranged from 20 to 47 micrometer. This classifies our emulsion as a macro emulsion. Now let's talk about some recommendation for future works and improvement based on my study. So the first one is to optimize homogenization parameter. While we found that 9,000 RPM for 30 minutes was effective, there might be even better combination of speed and time to improve the stability. Next, we can incorporate stabilizing agent. We can experiment with different formulation to enhance stability. We can also add antioxidant to protect vitamin E. Vitamin E is very prone to oxidation, which can reduce its effectiveness. Adding antioxidant to the emulsion can help protect vitamin E from degrading.
Throughout this study, I have relied on these sources to ensure the accuracy and the reliability of the information presented. I hope this presentation has provided a clear understanding of the topic of emulsion. Thank you for your attention and interest.